We are going to begin this section by analyzing the limit of functions as x approaches a number in two ways. We're going to do that graphically by looking at the graphs of functions and numerically by looking at tables of values. So first graph that we're going to look at will be the graph of this function, f of x equals sine x over x, around x equals 0. So imagine again, let's go from left to right. X is approaching 0 from the left. As x is approaching 0 from the left, imagine over here, the y value is going to be here. X is getting closer to 0. The y value is increasing and increasing and increasing. So in every case, you notice that as x gets very, very close to 0, I'm going to put an arrow here indicating x is getting closer to 0 from the left. I want you to notice what is happening to the y values. The y values are increasing towards 1. On the other side, something very similar is going to happen. Now, x is approaching 0 from the right. So we are here. That's the y value corresponding to this x value. Then I go over here. The y value is increasing. X is getting smaller, but the y value is getting larger and larger and larger. So then it appears that as x approaches 0 from the right, the y values are going up, and up towards 1. So graphically, what we really see is that the limit of the function at 0 seems to be equal to 1. Symbolically, we're going to go ahead and write this as the limit as x approaches 0 of sine x divided by x equals to 1. You remember that we mentioned in the introduction that sometimes we get a little bit lazy and instead of writing the actual expression, we just write f of x. That's totally allowed too. The limit as x approaches 0 of f of x is equal to 1. And something that I want you to notice here is that the function is undefined at 0. Because at 0, for a function like this, we would have f of 0 equals to the sine of 0 divided by 0. Sine of 0 is equal to 0. And as soon as you get something like this right here, you have the indeterminate form. This is saying that there is no value. There's no y value when x is equal to 0. This is actually undefined. So this is why when you look at the graph, you're going to see an open circle right here. However, the function is undefined at 0. But the limit exists. The limit is equal to 1. Because again, emphasizing, the limit is a neighborhood concept. You are analyzing what happens around 0, really close to 0. We don't care what happens at 0. The function may not be defined at 0, like in this case. What we care is for the function to be defined slightly on the left of 0 and slightly on the right of 0. And we want to see that the y values are converging to something, just like these arrows are indicating. We want to see that the y values are converging to a fixed real number. And in this case, the y values are converging. Converging means approaching. They are approaching 1. The function is undefined at 0, but the limit is not. The limit exists. The limit is equal to 1.